So welcome back to class, everybody. One second. So last time, this is what we did. We started with your questions on homework 4, and we're going to have some time for your questions today as well. And then we were going to do the practice exam in class, but a number of you asked me to delay that for today. So we moved that to today's agenda. And then we spent most of class talking about how to do network data in Python. So you learned about network X. You learned about how to associate data with edges, how to associate data with nodes. And you learned that there's a lot of algorithms that are network-specific algorithms that are already implemented in network X. So oftentimes, if you want to do something with a network, you can just do it in network X. And then towards the end of class, we spent some time discussing how to solve shortest path using a linear program. And we just started programming that. So we didn't get too far. We looked at the CSV files and we looked at some pre-processing. But we didn't actually get to using Pyomo to construct a linear program. So here's the plan for today. I'm going to start with your questions, either on the homework assignment or what have you. We're going to talk a little bit about the exam, which is going to be next Tuesday. And then we're going to do the practice exam in class. So that means that you're going to help me sort of create a program for the practice exam, the first practice exam that I distributed. So somebody asked me last time to give you one other practice exam, so there's a second practice exam that's on Canvas now if you want to practice a second time. And then we're going to finish shortest path in Pyomo, and we're going to do a different kind of linear integer program. We're going to do a facility location example, which is similar to shortest path, but different. Okay, so let's just begin with your questions. So anybody have a question on homework assignment or anything else? Yes?
Well, we're trying to get the center point, I guess, for each digit.
Yep.
Is that like an average? Like if we wanted to find the W for 3, we just find all the 3s and then some average for it.
Yeah, exactly. And there's a question on that about that on the assignment. So if you look sort of towards the end of the k-means classifier, one of the questions is that you can actually find the optimal solution really easily for that classifier. And it's exactly what you said. So if I want to find the optimal W's instead of using stochastic gradient descent, in that particular classifier it's easy because I'll take all the 3's and average them together. I'll take all the 4's and average them together and so forth. So yeah, that's absolutely correct. And it's kind of like taking the center point in 800 dimensional space.
Are we using SGD at all?
Yes, you should use SGD for that, right? So that's kind of like a warm-up to the more complicated classifier, which is the second one. And in the second one, you can't do that. There's not like a simple analytical solution like there is in the first one, right? And that one, we're just kind of lucky that there's an analytical solution that we happen to know. So one thing that you could use that for is you could check that your SGD code is actually converging to the right thing, for example, because you know what the right thing is, but you don't in the second case. Okay, other questions? Yeah.
For the exam, are there any modules that we need to install ahead of time? Because sometimes it'll take me 7 hours to install a module in 2 hours.
So I probably not. But I will use modules like SciPy and Pandas and so forth that we learned in class. Matplotlib, of course. I might ask you to do some plotting and things like that. Yeah, I won't ask you to install something new. Yeah. Other questions?
Will the difficulty of exam be close to the first practice or the second one? Because I think second is a little bit difficult.
Oh, you think the second one's more difficult? I thought the second one was slightly easier. So it's just a question of perspective, right? Yeah, I don't know. You can tell me what was difficult about the second one. So what was difficult about the second one compared to the first?
Oh, actually, because he told me so.
I see. Okay, so one thing that I think is a really important skill and something that I try to have this class focus on is your ability to learn all these things on your own, right? So you've had to do a lot of reading documentation, looking up things online on your own. And that's because that's how it just works in companies and wherever you go after you're done with this class, right? There's just too much stuff to learn for somebody to actually tell you all the stuff that you need. You kind of have to look it up on your own. So the reason I bring this up is because highly likely on the exam there might be something that you need to look up and understand how it works that you haven't used before. It will be from a module that you've seen before, right? But I might say this function might be useful to you, right? And then you'd have to go look it up and understand how to use it. So other questions? Okay, if not, let's talk just a little bit about the exam next Tuesday and how that's going to work. So it's going to be like a Canvas assignment. It's going to come out right at around 3:30, and it's going to be due at 5:30. So that means at 5:30, your ability to turn anything in for that is going to go away, right? So like there won't be a submit button anymore at 5:30. So that means just make sure to get it in before that time. So other things is you don't have to be here. You can be anywhere. Like you like to code at home, like with your desktop or in the library with your laptop or whatever. Just go and do it there. Just totally open internet, open anything. The only thing that it's not open is you can't talk to anybody, right? You can't talk to your friend. And similarly, you can't ask me any questions. You know, I'll be here just in case of some, you can't turn something in on Canvas, right? Like that is a kind of question that you might ask. But, no clarification questions on the exam, no questions about Python, nothing like that. But I'll be here during class time when you take it. So, yeah, unless there's any questions about that, I think that's kind of the general format.
Is there a timer on Canvas? As in, like, the time might not be using our laptop timer.
No. Yeah, I don't know how to set that up, and so no. Okay, so then let's do the practice exam. And the practice exam that we're going to do in class is the one with assignments. So let's just open up this assignments CSV file, see what it looks like. So we have a bunch of students and their associated group, and each group has produced a single write-up. So there's like one write-up for group 1, one write-up for group 2, and so forth. And I want to assign the write-ups to reviewers. And there were various rules that told me who can get what in terms of the write-ups, okay? So how would you start, or how did you start? How many people actually did this out of curiosity? And just out of also curiosity, how many of you were able to do it in 2 hours? Okay, so that's a reasonable sign. So how did you start? So here it is, I'm starting. So what'd you do first? Yeah, so let's say that the data is going to be pandas.read CSV, and it's going to be assignments.csv. Okay, so the name student is not defined. Say again? Let's see if this does anything. Okay, it's because I actually ran the CSV file instead of the Python file. That's what happened. Okay, so here's my data frame. It has all the students and their groups. Okay, so what should we do next?
I took the group part out of the group 5, 6, 7, so I just have the number.
So you kind of want to see how many unique groups there are, right? So let's do it like this. So those are my groups. And maybe, yeah, you know, maybe they're not numbered, but whatever. That's their names, their group names. Okay, so I can think of now as I having like one write-up for each group, right? Okay, so what do I do then?
Students from each group, and this is what I thought of. So maintain a list of which groups are not allowed for each of those students. And start with the first student, and then random like we know which groups are not allowed for that student. So remove those groups from this unique object, and then sample two of the index out of it.
Great. So that's pretty reasonable. So you're telling me several things, right? So one thing that you told me is that for each student, I need to figure out which write-ups are okay to assign to that student. And then you told me that I have to, like, out of the write-ups that are okay, I have to, like, assign one of them to the student, right? And you can think of these as separate operations, and it's one thing that I want you to kind of get used to is breaking up, like, big problems into sort of small, like, parts that are much easier to program as opposed to programming the whole thing at once, right? So one way that we might do that is to define, like, a class that's, let's say, assign reviews, right? And in the initialize function, I'm going to read in that data frame, and I'm going to compute the groups, right? And so one operation that you told me is that I want to figure out which groups are not allowed for the student, right? So let's say groups not allowed. And this function is going to just take in just a single student as an argument, right? Okay, so how do I figure out what are the groups? So okay, so what are the groups that are not allowed for the student?
There are two things. One is the group which they are in, and the other is where their partners in the same group are in.
Okay, so
if I've already assigned my partner to, like, my partner is assigned to group 8.
Yep.
Group 8 and the group which we are in, they are not in.
That's right. That's right. So there's two things going on. You can't get your own write-up, right? And if my partner has some write-up, I'm not allowed to get that one either, right? But not only that, but every student's going to get 2 write-ups assigned to them, right? Okay, so how do I do that?
One is by default we can maintain a dictionary of which with the key group number as the keys and the students as the values.
Okay.
And so we'll first by default the group in which they are in, that's added to this set. And whenever we are updating, whenever we are finding a group for a particular student, we update. We call this method and pass some group which is not allowed for that.
Okay, I mean, not unreasonable. So let me kind of break down what you said in a couple ways. So first of all, how do I find out what group the student is?
You do like DF in brackets DF.
Yep.
Equals whatever.
Yep, so that's going to find the right row. And then I need to look up the group, right? So that's going to give me like this student's group. Okay.
Instead of doing this, why not, like, when we are reading the CSV file, since we know that we have to access each element, just store it in a dictionary and then...
So pandas basically is a dictionary. Like, why would, it's kind of me like transferring from one data type to another, even though like I can access it just as well from the original data type. But you said another thing, which is I need to maintain like which students I assign to which group. So how do you guys want to do that? There's like many ways to do it, but which way do you want to do it? So I have to know like this student's partners, what reviews they got assigned.
Dictionary would be a good option.
So you want something like this. Let's say, let's call it assignments, right? And it's going to be a dictionary. And at the beginning, I want to say that nobody is assigned anything, right? So what's going to be the key to this dictionary? A student name, right? And what's going to be a value to this dictionary? The group. So let's say that I'm one of the students in the class. So at the beginning, what's going to be the value that's associated with my name? Like an empty list, right? Eventually, it's going to be like 2 lists. So here's our data frame. So I don't know if you know this dict from keys, and we can go data frame.name. And I forget exactly how from keys works, but okay. So a new dictionary is with keys from S and values equal to V. So if I do something like from keys df.name, it's df.student. I created a dictionary with all the names as keys, right? So one thing I want to do is put in an empty list here. But I'm slightly worried about this because one thing that might happen is something like this. Like, let's say that for this person, I append Fred. And let's look at the dictionary again. And Fred got added to everything. So why was that? It's because it actually initialized it with the same list, right? So lists don't get copied, like we talked about towards the beginning of class. So if I want to initialize it with an individual empty list, I have to actually do a for loop, okay? So let's just do the for loop here. So for name in df.student, self assignments of this name is going to be equal to an empty list, okay? And I might want to debug this as I go, so here I'm going to do if name equals main, and then AR is assign reviews. Okay, so now I can do things like run this assign.py, forgot a colon, run assign.py, and then look at ar.assignments, and it's all of the dictionary that I created. Okay. Okay, so now we're back to this function. So now I found this student's group, so I'm not allowed to have that one. But I'm also not allowed to have all the reviews of all of the partners. So how do I do that? So how do I find out what are the assignments to all the partners of the student?
Using this dictionary with a find
Yeah, but first I need to find his partners. So somebody else. Yeah. Yeah, so I need to look up so for partner, I need to find out all the partners of this person. So how do I do that? So df dot right. Absolutely. And then I need to take a look at the student part of that, right? Because I need their names. And so partner is also going to iterate over the student themselves, right? Like, is that something that I want, or is it not something that I want? Yeah, I want that actually, because I don't want to assign this person the same review. Like, if I've assigned them one review before, I don't want to assign them the same one next time that I'm here. So that's why I actually want to iterate over that person as well. Okay. Okay, so what do I do in here? I mean, yeah, anybody? Yeah, I'm trying to make a list of the groups that are not allowed for this student.
Partner dot set or whatever the. You want to look up the group sets in or viewing.
And yeah, and where do I find that? So not quite. So I'm iterating over the partners of this student, and how do I find out what reviews were assigned to those partners? Yeah, it's in this assignments array that I'm creating, right? So it's not in DF yet. We might put it in DF later. And that was actually one of the choices when I said you could store the assignments however you want. You could have created two new columns in DF. That's like review 1, review 2. And we're going to do that at the end. But for now, let's just use this other data structure that we've created. So here, I do self-assignments of partner, right? And that's going to return a list, and I want to extend answer with this list, right? And then I want to do something like return set of answer, right?
Should you add self.df?
Where? Oh, yeah, absolutely.
Or you can pass the df to the...
No, I want to do self.df because there's going to be really only one df that I'm going to be working with, so no reason to pass it around. But yeah, great catch. But so, okay, so this is one of the other things that I do. Now that we've broken down the bigger problems into little sort of sub-problems, I sort of go and debug each of those sub-problems as I'm going along, right? So let's here call group not allowed Okay, so we got an error. So it looks like it's right there on in the for loop. Okay, so it's possible that this is not quite returning what we wanted to return. So let's see what it does return.
I think you need some self.df in the initialize function.
Didn't I put one?
Not for all of them.
Yeah, great catch. Okay. Okay, so let's see what this group is. Okay, so one of the issues is that we thought this group is a string, but it's not a string. It's one of these dictionary type objects, right? So how do I get out the actual string value?
I use this.
So putting str
Or value.
Yeah, so let's do this. Okay, and then if I look at ar.df, yep, that's the only group that's not going to be allowed at the beginning. It's just group 8, right? So at least so far, so good. Okay, so I have one function that's going to tell me what are the groups that are not allowed for the student. So what's another operation that I need to actually do these assignments?
One question.
Yeah.
The function group not allowed. You are storing both group information and the student information in the same. Is that in the same list?
So for groups not allowed, can you ask your question again?
Yeah. For this group is a group information like group 8, group 7. But
Yep.
for the self-assignment partner, it's going to be the name of the student, right?
No, this is going to be the name of the groups that this student is assigned to review.
Oh.
Right, so partner is a name of a student, but assignments is a list of groups.
So you're going to store the group information in the assignment.
That's right, which is, which reviews you're supposed to do, for example. Okay, so tell me the next operation that I need to do to assign the reviews to the students.
You should balance the number of groups.
Yeah. So how about this? Like a function that's called assign a review, and it takes a student name, and all I have to do in this function is just for this one student assign him one review, right? And this is going to be nice because then the way that I'm going to assign all the students is just by looping and calling it twice for each student, right? Okay, so in this function for one student, I have to assign one review. And when I do it, I have to worry about what you said, which is sort of balancing the amount of assignments that I have for each group. Okay, so what should I do in this function?
One thing you can do is get a key and see if it is on your group not allowed list.
Get a key.
Like, well, if you have a dictionary of groups, I think, and then you could basically choose a key and use groups not allowed to see if, I guess, the key you've chosen is allowed or not, and then you could assign a student.
So what do you mean by the word key?
Like, I thought we had a dictionary.
Yeah, we have assignments that map student names to what groups they're reviewing.
Okay, sorry. Never mind. Okay, I need to think about it. Sorry.
Yeah.
From the whole set of groups, subtract the whatever you get from group not allowed, and randomly choose one group out of the result.
That's not unreasonable. So let's start with that and then change it a little bit, okay? So all groups is self.groups. And I forgot exactly how these set operations work. So there's a difference operator, and it might okay.
When you decide to use set?
Oh, why did I decide to? I don't have to. It's just set has a nice way of subtracting, like one group of things from another group of things. So the only reason I did it is because this is groups not allowed, but eventually I'm going to want the groups that are allowed which made me think I'm gonna, like if I did it with lists, I'll probably have to iterate or something like that. But with a set, it's a built-in operation, so it saves me a for loop.
Also, it won't have duplicate values.
That's right. That's right. And there won't be duplicate values. Exactly. Okay, so allowed is self.groups, and you want to say that that's minus self dot group not allowed for this student. Okay, so that's going to give me all the groups that are allowed. And then what you wanted to do was something like this. And then random has a function choice that chooses a random element from a non-empty sequence, right? So then I might do assignment or a review is equal to a random.choice from what's allowed. And then how do I actually assign this review to this student? Self.assignments for this student, I'm going to append this review, right? Okay, so we're going to come back and edit this a little bit because this might sort of create a bunch of imbalances in the groups. Just randomly, it might be the case that one group gets selected a lot more than another. So we're going to do something slightly more balanced in a bit. But let's say that for now we're satisfied with this and we want to finish like all the code so that we're assigning things to everybody, right? So let's write another function, assign all. That's going to assign all the reviews to all the students. So help me write this one. Okay, so I'm going to iterate over the students and then twice, right? So let's see if this works. And then maybe ar.assign all. Okay, so I got some errors. So let's debug. So that's where that's how I always do these things. So let's see what allowed is. So allowed seems to be this big set, but random.choice doesn't seem to work very well for me, and that's because this says that set does not support indexing. So how can you help me solve this error? What should I do here? Yeah, change it to a list right there, and then hopefully it should work. Okay, so let's see what assignments looks like. And you know, not crazy. Like we've assigned groups to all of the students. We've assigned 2 groups to all of the students. But help me do a little bit more balancing in terms of the assignments. So how do I make sure that each group has about the same number of assignments? Well, first of all, how do I even check how many assignments each group has? Say again? So you want me to use a dictionary where I store the count for each group. Say again? If the group number is in the you're basically saying kind of iterate through here and count how many times group 3 appears. Not that I know of, not a single function. But some of the rest of you also said something like create another dictionary that stores the counts on how many times this group was assigned, right? So let's do that. So self n reviews, right? I just want to count the number of reviews. That's also going to be a dictionary. And it's going to kind of look like this. And then because it's not a list, it's going to be just a count. I can do dict from keys and then self.df.group. And its initial value is going to be 0. Okay, so I've initialized the number of reviews to 0. And then when I assign a review, here I should increment it by 1, right? So self.n reviews for this group is going to be incremented by 1, okay?
Did we add this group to the groups not allowed? We didn't do that, right?
Which group to group not allowed?
When we assign a student a group, we need to add it to the group.
Yeah, so when I assign a student a group, why is it going to be not allowed next time that I see it? Because that student's going to appear as a partner here, right? So his assigned reviews are going to get added to the list of things that are not allowed for that student. Okay, so let's run things and take a look at what kind of imbalances we're getting. Okay, so we get some groups with 7 reviews and other groups with 2 reviews, okay? Not quite as nice as what we want. So help me make this nicer. So help me make sure that each group is getting about the same number of reviews. And that is basically just going to be some edits, I think, to this function. So yeah, what should I do?
I think in order to make everything balanced, you need to do something before random choice over there.
Oh, absolutely, yep. So what do I do?
So in my thinking, at first you will create a list of every group.
Yep.
And each time you assign, you drop that one from the list, and you only create a random choice in the remain group only. So at first it will have 15 groups.
Yep.
So
that's groups.
Yeah.
Yep.
So each time you do a review by that random function, it will choose one of them, right?
Yep.
And you assign that one and you drop that group.
Okay.
There will be 14 left, right?
Yep.
So the next time you only random choice in that 14.
Yep.
It will drop gradually, right? When it becomes to 0 and you have many students left to assign, you create a full group.
Yeah. So what you're saying is not unreasonable. Okay. So it's slightly different than what I had in mind. But let me just kind of explain the idea here. So the idea is to kind of keep a count of how many times each group was assigned as we're assigning it, right? And so at the beginning, we've assigned no groups. So all groups are at 0. So all groups are available. So as soon as you assign a group, we're going to remove that group from the available list, okay? As soon as we assign some other group, we're going to remove it from the available list. And when the available list goes down to 0, we're going to go back to all 15 groups being available. Does that make sense? So let's give that a shot and see how and if that is different, right? So let's say self.available is self.groups and I just want to make sure, I want to create a copy of it. So that's why I'm going to do self.groups.copy, right? So why am I doing .copy? It's because I don't want to edit my original group list. I want to just edit this new set of groups that I've created. Okay, so what you want to do, so what do I do? I mean, how do I continue here? So at the beginning, all the groups are available. So how do I edit this function, assign a review?
when the group is not represented, just add it if it before the choice, like if the set is empty, then you add.
So the first thing I need to do is not choose from all groups, only choose from the available groups, right? The next thing I need to do is right here check if what's allowed is empty set, right? So if length of allowed is 0, that means I can't choose any group. Then what am I going to do? Self.groupsAvailable is self.groups.copy, right? So I'll go back to all of the groups being available. And then allowed is going to be the same thing, right? So what else do I need to do to this function?
Remove that assigned group.
Yeah, I need to remove the assigned group from the allowed set, right? So at the end here, self.groups available is self.groupsAvailable minus a review, right? Is that reasonable? Okay, so let's rerun it and see what happens. Much nicer generally, right? So now we don't have the 7s and the 2s. Now we're getting just like 4s, 5s, and 6s. And this might be good enough. Like, you might be perfectly satisfied with this and turn it in. And if you wanted to go a step further, how might you do it? Like if you wanted to make sure to try to be even more balanced than this, how might you do it?
Maybe find them.
Yes.
I computed a maximum limit that each group could have to ensure a balanced distribution. So like 37, I think there were like 38 students or something across 15 groups, and you knew there would be 2 reviews. So I think that ended up being like a maximum of 6 for a balance. And then associated with each, I guess I kept count associated with each group, and if my class tried to assign a student to a group that was already at capacity, it just chose again.
Yeah.
I had like a little loop in there.
Yeah. So that's one of the ways that you might change it, is that instead of sort of keeping this set of groups allowed, I might write a function that computes which are the groups allowed. And the way that it does it is by looking through this dictionary and taking out the groups with a minimum number of reviews assigned to them, right? And then adding some other sort of if statements to make sure that, if it's still empty, then don't look at the minimum, but look at the minimum plus 1, or look at the minimum plus 2, look at the minimum plus 3, and so forth. Does that make sense? And that might give you an even more balanced split in here, and likely it'll give you a even more balanced split. Okay, but let's not worry about that right now. But let's finish this problem by writing out the answer, right? So the final thing I want to do is write out a CSV file that basically has all the information of the original one, like the student's name, their group, but I want 2 new columns, which is the first review that this student was assigned and then the second review that this student was assigned, right? So we're going to write a function that's write out the answer to a file called fname. So that's some string that got passed into this function. Okay, so help me create the thing that I need to write out. So what is it going to be? So how am I going to write out this CSV file that has the student's name, their group, review 1, and review 2? Yeah, exactly. So self data frame review 1 is going to be nothing. And self data frame review 2 is going to be nothing. So what I do with these 2 lines is I create a new column in self data frame called review 1 and review 2. And at the beginning, it's nothing for all of the students, right? So now I need to actually populate this with the assignments that I have. So how am I going to do that? So I don't know if you guys remember this, but assignments is a dictionary, right? It maps a student name to this list of two things that we're going to assign. So here I'm iterating over the dictionary. So K is going to be the student name, and V is going to be the list of the two reviews. Okay, so help me write what I need to do inside this for loop. So what do I do? Self.df right, so that picks the right row, and that picks the right column, and I need to set that equal to what? Yeah, V0. And then a similar thing for V1, right? And review 2. Is that right? Okay, so now I've added these two columns and hopefully populated them with the right thing. And then how do I actually write out the CSV file? Yeah. Okay, and let's see if this worked well by looking at the data frame. Yeah, so we have the column student, group, review 1, review 2. And, you know, just by visual inspection, making sure that no student got assigned their group, it looks reasonable, right? And then we could look at N reviews to see how balanced it is. And in this particular case, it was slightly more balanced than when we ran it before, or maybe not. We still got 2 4s.
What's this idea?
Say again?
What is self.df?
Okay, so why did I do this? That's a great question. Why did I do df.ix? So this is indexing, right? It says index this row and that column, okay? But why did I do ix instead of just not that? Right, so you may have thought of just doing this, right? Okay, so first I got an error over there, but there's some other issues with it. Okay. So let's try it. Say again? All right. So I got some errors. So the error I got is a value is trying to be set on a copy of a slice from a data frame. So the issue is that when you're indexing like that, you're not actually getting at the actual data frame data. Like what Pandas is doing is it's returning a copy of that data for you when you're doing that slicing. So when you do IX, you're actually getting at that actual data. Okay, so that's why I did it that way. And again, the way that IX works is you specify a row here, and then you specify a column. That gets you to a particular part of the data frame, and then you can put a value in that data structure right there. Okay? Okay, and then we can look at answer, and it looks reasonable. And then maybe you want to get rid of this first empty column, right? Because these are the auto-generated indices from pandas. So does anybody remember how to do that? Yep. Okay, so now we've completed the exam and we can turn it in. Okay, so definitely possible. The main thing that I think helps is the kind of question asking that we did together as a group, right? Which is breaking down the big problem into little sort of sub-steps and then building up on those sub-steps as you're going through it, right? So if we try to do the same thing as a bunch of nested for loops without maybe a class, without breaking it down into little operations, it's much harder to think about. And because it's much harder to think about, it's actually much harder to debug and to actually get the code running. So besides easier to program, breaking it down into little steps is going to really help you do things like debug it, which we did at each one of these with each one of these functions, right? So I wrote like 5 or 10 lines of code to do one thing, and then I debugged those. I wrote 5 or 10 lines to do the next thing, debug those, and so forth. Okay. So any questions about that? Yeah.
Are we going to be expected the comments are?
Yeah, so that's a great question, and yeah, absolutely. Please comment your code, and it's the main comment that the TA gave me on your codes in general for your homework assignments, which is that very few of you, if any, add any comments to your code, and so it's incredibly difficult for him to actually understand what your code is doing where. And especially for an exam, that's extraordinarily helpful, because your comments are going to allow him and me to get at the idea that you had behind that code, right? So they might have a bug in it, you maybe didn't quite debug it, but your comment is going to tell me what you were trying to do, and is going to maybe give you some partial credit. So yeah, please comment both on the homework assignments and on the exam. So other questions? Yeah, Pratik? Oh, you're not. You could do it in a different way. For me, this is the easiest way. What's the downside of writing a bunch of functions? Can somebody tell me what the downside is of writing a bunch of functions to do the same thing? So let's say that I took the exact same code, right? It works. But instead of having it as a class, I wanted to have it as a bunch of functions. What's the downside of that? So there's another way of saying what you said. So say again?
You have to repeat the same block of code.
The downside is I have to pass around a ton of information from one function to another, right? So what do I have to pass around? I have to pass around the data frame. I have to pass around groups, maybe groups available. I have to pass around assignments. I have to pass around N reviews. So now these functions, instead of having one parameter, which is just the student that you want to assign to a review, are going to have like 5, which is the student I want to assign to a review, the data frame, the groups available, and so forth, right? And so it just makes it a lot harder to read, for one thing. And then a second thing, it makes it harder to do things like the following. So we had written all of this, and then I wanted to add N reviews at the end, right, when we were talking about balancing. If they were functions and I wanted to add N reviews, I would have to create that dictionary somewhere and then pass it around through all the function calls, right? But here I just stick it into init, and then it's available in all of the functions for the class.
I understand that it's a much better way of writing code. I get your point, but if we just want to get the output, sometimes it's just easier to write the entire code in main itself.
So I claim it's not. Okay, I understand why you're saying that, but I claim it's not because it's harder to debug, it's harder for you to read, and you're going to get lost in your own code relatively quickly. And so I understand why you're saying that, because that's how, like a lot of people who just kind of starting programming will do exactly what you said, which is write the code with a bunch of nested for loops in main itself, but it's much, much more difficult in general to debug than this is. Yeah.
What about instead of passing down all the functions, they could just make all of them global, right?
Yeah, so that's kind of Pratik's idea, is to just make everything global, right? So, yeah, that will work, but yeah, generally, I think much poorer style.
Would you be like deducting marks for it, like for not writing it properly?
So I may, but not much. And this is the reason. Okay, like ultimately, I care about your code working, right? So that's why not much. But the reason I may is because the entire purpose of having these exams is to get you guys to the point where you can pass coding interviews with companies, right? And a coding interview is going to be exactly this. They're going to give you some problem like this. They're going to give you an hour. They're going to maybe tell you to open up Google Docs or whatever and write code for it, right? And if you write code that's all in main, like you're going to do a lot worse in the review, in that like interview, than if you do it this way, okay? So maybe, but not very much, okay? Other questions? Okay, if there are no other questions, let's continue where, yeah.
Are you familiar with integrated development environments? Like,
Yeah.
do you have a comment on using those or not?
I don't use them, but some people may find them useful. So it's kind of dependent on what you get used to.
You don't have anything against using them?
Oh, no. Yeah. Some people really like them, and they have like various functionality that's available that's not available in my little text editor. I mean, my text editor, the main thing it does is syntax highlighting, right? But IDEs, yeah, let you do all kinds of other things. Like for example, like using a debugger might be significantly easier in an IDE than otherwise. Other questions? Okay, if not, I want to get back to using Pyomo to solve shortest path. And let's just remember briefly where we were. So we had created, or we had just written on the board, a linear program to solve shortest path. And a linear program generally involved these things: some sets, some data, some variables, an objective, and some constraints, right? And all of those things are what we need to describe in Pyomo to get our shortest path example working. And for shortest path, the variables were these yij's that are 0 or 1, which is, am I going to take edge ij on the path from S to T? Our data was two things: Cij, which is the length of an edge, and the second piece of data that we had is these node imbalances that were on the right-hand side of the network flow inequalities, okay? And so our overall linear program looked like this: minimize the sum of the Cij's times the Yij's. The Y's are positive. And then these network flow inequalities that basically counted the number of things going into a node versus the number of things going out of a node. And that difference has to be equal to whatever the node imbalance piece of data is. And where we were was we were just trying to describe this in Pyomo so we could get it into a solver. And just to remind you how Pyomo and the various solvers are related, is Pyomo is a modeling language. It allows you to describe optimization problems, but it doesn't actually solve anything. So what actually does the solving are solvers like Cplex, Gurobi, GLPK, MOSEC, IPOpt, and so forth. And with Pyomo, you can take your description and send it to any solver. So if one of them doesn't work, you can take the exact same code and try a different solver with it to see if that one works. Okay? And let's read over or remind ourselves what we had done last time. So for our shortest path example, we had two files. So it was a nodes and an arcs file. So the arcs file looked like this. So it was an arc from A to B, and that was its length. So from A to B, we had a length of 1, and so forth. For the nodes, it was the node name, and then one of the pieces of data associated with a node was the imbalance. Okay. And so what we did in these first few lines is just read in the CSV file. We set the index for the data frame so that instead of referring it to the first line of the node file as line 0, we can refer to it as line A, okay? Which is going to allow me to index the data frame with a node name as opposed to a number. We sorted these indices and so forth, and then we figured out what the node set and the arc set is, and we just got to create model, which is going to be the first, our first usage of various Pyomo things to describe the optimization model. So the way that Pyomo creates optimization models is you first have to create a model object. So that's us creating a model object. So PE stands for Pyomo environment, and we're creating one of the built-in model objects there. But so far, it doesn't have any variables in it. It doesn't have any sets. It doesn't have any objective constraints or anything. So the first thing that we need to do is define what the sets are for this model object. Okay, so why are sets important in describing an optimization problem? They're important for two reasons. So one reason is that these sums that appear in a math program are over some sets, right? So here I'm going to be summing over edges. Another reason is that the constraints appear over some sets. So here there's a single constraint for each node. And a third reason is that the variables are indexed by a set, okay? So here I have a variable for each edge. So that's why defining a set is an integral part of a modeling language. So here we've defined the node set and the arc set. So those are the set parts of my model. So now let's create some variables. So those are going to be the y variables. And here the .y and the .arc set and the .node set, those are names I made up, right? There's nothing built in about that. What is built in is Pyomo environment.set, and what's also built in is Pyomo environment.variable, right? Okay, so here I'm creating a variable, and I'm creating one variable for each arc in the arc set, okay? So that's how we're saying that the y's are going to be indexed by arcs. And here I'm saying that the y's are going to be non-negative real numbers. So that's like saying y is bigger than or equal to 0. Okay. So Pyomo has other things in it like binary, like I could say p.binary, and then that means that the variable is a 0, 1 variable. Okay. Okay, so now that I've created my y variables, the next step is to create the objective. So let's read how we're going to do that. So in general, for both constraints and objectives, Pyomo defines them using functions, okay? And in this function, you can have arbitrary for loops and so forth that create the expressions to make that sum or that inequality be whatever you need it to be for your model, okay? So here's a function that's going to define my objective. And these functions always take a model object as their first argument, okay? So this is going to be a function that takes in a model object as its first argument. And let's see what it returns. So remember that the objective we wanted was the sum over all edges of y times Cij, right? So let's read this. It's the sum over all edges, so for E in self.arcset, right? So here I'm iterating over all edges in the arc set of the y variable for that edge times the arc data for that edge, okay? So here again, I'm using that .ix to get into the particular value of a data frame, right? So I'm doing arcdata.ix. The first thing I have to do is specify a row. So how come when I pass an edge object in here, it specifies a row of the arc data frame? Yeah, exactly. It's because I changed the index, right? I made the index of that be edges, right? So when I pass in an edge, that actually specifies a unique row in that data set. So here, I'm going to the unique row that corresponds to that edge and taking a look at the arc data part of the data frame. Does that make sense? And does it make sense how this expression exactly corresponds to yij times cij and the sum of that over all edges in the edge set? Yeah? Okay, so great. And then the last thing that we do is define a Pyomo objective using this function. So the way that you do that is Pyomo environment objective. You say that the rule to create this objective is this function you wrote, and then you pass in a sense, which is, do I want to maximize this objective or do I want to minimize it? In this particular case, I want to minimize it. Okay. So let me just create a bug here purposefully, so that we can go and debug this and play around with these objects a little bit to see what they look like. Okay, so I divided by 0, which basically dropped me right into this line of this function. Okay, so here I want to do a couple of things. First, I'm going to call this objective rule, right? It's a function like any other function, so I can call it. And what it expects as its argument is a model object, right? And the model object that I have is self.m. So I'm going to call that function by passing in self.m. And what it's going to return is a Pyomo expression, okay? So that's the expression that was created by that sum. So the expression is YAB plus 3 times YAC plus 4 times YAD and so forth, right? So now I can go and check if this actually is what I want to be happening with my data. So this is a really useful way of debugging your model creation as you're creating it, right? You can actually call these rule functions to see what they're doing. So another thing you can do is print. So here I created self.objective. That was a PE objective. So I can call pretty print on that objective, Pyomo objective object, right? And what that does is it prints out everything that Pyomo knows about this. So, for example, it knows that its sense is minimized, and it prints out this expression that's associated with that objective. Make sense? Okay, so objectives are kind of nice and maybe slightly easier than constraints because there's only one of them usually, right? So that's whatever we're going to maximize or minimize. But there's often many constraints, and they have both a left-hand side and a right-hand side, whereas an objective just has a single expression, right? So let's see how we're going to create the flow balance constraints. So it's going to be very similar to an objective. Again, it's a function whose first argument is a model object, but its second argument is which constraint are you trying to make, okay? So in particular, for shortest path, we're going to have one network flow type constraint for every node, right? So I'm going to create one function that creates network flow type constraints. So another way to have done it is to create, as many functions as there are nodes, but that's not a very nice way to do it, right? Because you go and you change the data set, and it's going to be very hard for you to sort of like change your code correspondingly. So I want to write something that automatically creates this constraint depending on which node it is. So that's why this flow balance rule is going to take a modeling object or a model object as the first parameter, and the second parameter is going to be a node name. Like, that's the node for which I'm creating the node balance constraint. Okay. So let's read what the inside of it is doing. So what do I need? What do I need to create the node balance constraint? I need to sum over all the edges that are coming into the node and subtract over all the edges that are going out of the node, right? And it's going to be the same regardless of which node it is, regardless of whether it's ST or any other node. So in here, I have to figure out what are all the edges that come into this node and what are all the edges that go out of it. So let's see how I do that. So first, I'm going to take this ARC data set, and I'm going to reset the index. So that means I'm going to get rid of the fact that it's indexed by edges, and I'm going to go back to getting indexed by 0, 1, 2, and so forth. Okay. The next thing is I need to figure out what are all the predecessors of this node. So what are all the nodes that have an edge that that's coming into this one? So how do I do that? I look at arcs. I make sure that the end is equal to the current node that I'm looking at. And I want to look at the start of that. So that's going to give me all the predecessors of this node. Does that make sense? So similarly, all the successors, I take a look at arcs. I make sure that the start is the current node, and I want to look at the end of them. That's going to give me all the successors of this node. Does that make sense? Okay, so now let's take a look at what the constraint looks like. So I'm going to sum the y's, so m dot y. And which y is it? Well, it corresponds to an edge that starts somewhere and ends at this node, right? So those are all the edges coming into this node. And what is p? Well, it's one of the predecessors of this node, right? So that's the first summation expression that we had written out. Does that make sense? So let's take a look at the second one. It looks similar. Sum all the y's that start at n and go to s for any s that's in the successors. And the constraint is that this sum has to equal, so the way that I do that is with a double equals because it's sort of forcing, it's a constraint, right? So I want to force this sum to equal something. And what should it equal? Well, it should equal to the node imbalance, right? So how do I get at the node imbalance? It's in node data indexed by this node in the imbalance column. Does that make sense? So this single function, as I iterate over n, is going to create all the constraints for all of the nodes. Does that make sense? Okay, so let's see, let's just finish with this next line and then we can debug from here next time, which is we're going to create a constraint and now we're going to create one of these constraints for every node in the node set. So that's what this parameter says. It's basically saying call this function in a little for loop where you're iterating over every node in the node set. Does that make sense? Okay, so let's end here. So we'll pick up again next Thursday, and next Tuesday is going to be the exam. So I'll be here, but you don't have to be. You can take the exam wherever you want. So, yeah, it starts at 3:30, and it'll be due at 5:30 on Canvas. It's going to disappear from Canvas at 5:30. So thanks a lot for listening, and I'll see you all next week.